Hello ladies and gentlemen, and welcome to another video. In this video we're going to be creating a portfolio simulation using Python, Pandas, Numpy, some other wonderful stuff. It's going to build somewhat on the previous video I did on Monte Carlo simulations, because we are going to use some of the same code. We're just not going to be plotting it, we're going to be using it to sort of figure out what the value of a portfolio will be in n number of years' time. So the very first thing we need to do actually is something I've already done. So here's one I made earlier. We need a little JSON file which contains a portfolio. So we'll explain what this data structure is that I've created here. If you don't know what JSON is just sort of markdown file. It stands for JavaScript object notation. So in this case, we've got a portfolio object, which is an array of these little objects here. And each object contains a ticker, a name, a type, and a weight. So the ticker corresponds to the ticker of the stock or index, in this case, that we need to get the data from Yahoo data reader. Pandas data reader. We have the name, which obviously is the name of the instrument. We have the type, which is, in this case, I've only considered indexes or stocks, because most people will have a portfolio full of indexes and stocks. Maybe they'll have some bonds in there, maybe they'll have commodities, but I've left those two out. There are other things you could also do here, but just to keep things simple for this video, we're only going to consider indexes and stocks. Then I also have a weighting of the portfolio, which is a bit lopsided. So we have 10% in the FTSE 250, 80% in the Vanguard Emerging Markets Fund, 10% in United Utilities, and 10% in BHP Group. So the code for this will be in the link on codeyogi.org.co.uk, should I say. And yeah, you'll be able to just download this and then modify it to your heart's content or whatever. So you can just get started. So let's start off by creating a little Python file. We'll call it main.py. First thing we're going to do is we're going to add the little shebang at the top of the file, which is coding:/UTF-8. Now that's because I think, if I remember correctly, Python is normally in Unicode. But we have some characters that are non-ANSI characters, the £sign or the $sign if you're in America, which we're going to be using as part of the output of this program. So we need to set that so that Python doesn't kick off. Okay, so let's get started with all these imports we have to do. So we want to do from datetime. Oh my god, he's already messed up. Import datetime. Have a guess what we're going to be using that one for. I bet you it's dates and times. Then we're going to import JSON. That's so we can read that little portfolio thing we just created. Import NumPy as MP. Standard in Java, just to say NumPy as MP. As it is to do Pandas as PD. Okay, something you... Oh, what the hell's happened there? Something you're going to have to be aware of here as well is that we are going to say import from Pandas data reader, import data as WB. For this tutorial, you are going to need Pandas data reader above version 0.7. So I'm currently on version 0.8. The way to do that is just to install the latest version. So you can do, I think it's pip install pandas data reader, which is really annoying, and that will give you the latest version if you haven't already got it. I think then if you already have it and you want to upgrade, you can just do pip upgrade install pandas data reader in your terminal. So over here we would do that. So let's just try it actually. Pip upgrade install pandas data reader, just to check I've actually got the right command. Oh, smeg, I haven't. I think it might be pip install upgrade. I really should have checked this before this video, but I didn't because I'm a calamitous mess, as usual. Okay, right. Okay, there we go. Yeah, that's the right one. So we want to do pip install -- upgrade pandas data reader. So you need to be on that version, at least 0.81. The reason for that is because one of the data sources we're using, there's some sort of bug that prevents you using it in version 0.7. So yeah, facts. We're also going to import from scipy.stats. We want to import something called the norm function, which we imported in the last video on Monte Carlo, the Monte Carlo simulation. And we're also going to import something called gmean, which stands for the geometric mean, which we'll get to at some point. Let's go ahead and define some of the constants. Okay, so start date is going to be that's 1st of January 2007. That's just when we're going to start getting data from. It's not the current date or anything like that. How many years into the future? Well, let's say, because this one we could do retirement. So we could say, okay, so you're going to retire in 40 years is the typical career. So let's assume you've just started your career. We'll say years is equal to 40. So we're going to forecast into the future the value of a portfolio in 40 years. Next we need to have the days in the year. Now in the previous video I made a bit of an error because what I did was I had 365 days, but I should have really had 253. The reason for this is because this is the average number of trading days in a year, so that's when the markets are actually open, because otherwise we're just going to compound interest or returns onto days where the markets wouldn't have been open, so it would be somewhat inaccurate. Then let's pick a value for the amount of money you would save in a year. So I don't know, this is going to be just a random number, so let's say something like let's say, I don't know, £100 a month. That's a woefully low level of savings, but we're just going to say that. Then we're going to say daily savings. We need to get this so we can actually figure out how much each day we should add on average. You'll see what I mean. That was very poorly explained as usual. So then divide that by the days in the year. Portfolio value is something else we probably want to put in here. Let's say we're starting with a portfolio value of £1,000. Yes, that'll work. Okay, so the next thing we're going to do, let's do the simulation stuff. We did this in the last video. This is going to be very similar to what we did in the last video, except there's a few modifications that I've done in doing this. So thinking about it, we need to do log returns. So this is the logarithm of the returns. So MP log 1 data, get the percentage change. So if you saw the last video, you will see that this is very familiar. What we're doing here though is we're going to pass in the data that we're going to get, and then we're going to do all this analysis. In fact, maybe it makes sense for us to actually get the data first. This is probably a better idea. Okay, let's change tax. Let's start getting some data. So actually we'll get the stuff from the portfolio first. So we'll say get portfolio. We'll say with open. I've called my portfolio thing portfolio.json, and because we're in the current directory where the file is, so if we just go over here, ls, I haven't saved this file yet, so if I quickly save it, yeah, we've got main.py and portfolio.json, there we go, .json in there. My god, that was horrendous. So we'll say portfolio file. Okay, so what we're doing here is we're just opening the file, right? And we're getting the bytes from the file. Then we're going to take we're going to sort of read it in. So we're going to say portfolio JSON is equal to portfolio file dot read, and then we need to actually figure out what it is. So we say JSON loads portfolio JSON, not file, and we want to get the portfolio from that. So remember the file, we actually have this object called portfolio, and that's what we're going to get. So we're only going to get the portfolio. So you could also have other stuff in this bit for whatever reason, but we're just going to get the object called portfolio, which is, like I say, the array of these little objects. Right. Well, let's check this is working. So we'll say print get portfolio, and that should do some stuff over here. Oh no! See, good, we're checking this. From pandas import. Why have I done that? Import pandas as PD. There we go. There you go. So now you can see we've actually pulled in all the data. Looking good. So that works. So we know that little method works there. So let's get on with the next stuff. What do we need to do? Well, we need to then figure out if we're going to get the data, how we're going to get the data. So we'll put one above here, and we'll say, let's get the data, and we'll pass in a stock object. So we're going to call these things, this bit, a stock object. Even if it's not a stock, I could probably call it something else, but stock makes sense. We'll call it that. So we need to say data pd.data frame. So we're just going to create a cheeky little empty data frame. Next, this isn't the best idea. I was just thinking now, it's too late and it will make the video too long. So we're just going to do a quick bodge. Essentially, if you remember, we have these two types of object here. We have the index and we have the stock. Really, we should have each of these when they get read in, we should import them, or when we deal with them, they should be constructed into a class that has its own methods, so that when we call that method, it acts correctly for that type. But we're not going to do that. We're going to do an if statement. You'll see what I mean in a second. So we're going to do this stupid thing. So this is I'll tell you why this is a problem. So we're going to say if stock type is equal to index, and then we're going to do some stuff, right? Otherwise, we don't need to have another if statement or anything like that. We're just going to say data WB data reader. That does not say data reader. Data reader stock. We'll get the ticker. So we're going to pass in the ticker. So this is very similar to what you saw last time if you saw the video where we get the data. We're going to say Yahoo because we're not in the if statement at the moment. The if statement is in Python. We have to indent the line. So if in the case that this isn't an index, we're going to say this is a stock. So we're getting it from Yahoo, and we're going to say start is equal to the start date. Okay, then we're going to say return get simulation data, like that. In the case that this is an index, we need to do something ever so slightly different. So we're going to copy this like this. And we're going to say that Stook. That is just an alternative data source that instead of getting stock data, holds the data about indices. And that is how we're going to do that. So this wouldn't work. Oh, sorry, this would work. This wouldn't work with Yahoo because Yahoo doesn't recognize this ticker. This, for some reason, is being treated like a stock by Yahoo, and it's not present in the Stook data, so it's only present in the Yahoo data for some reason. So that's being treated like a stock when it's technically an index. A bit stupid, but this is something that you'll come to sort of see. So why is this bit of code stupid, and why haven't we done it a better way? Essentially, think about this. I mentioned earlier that we could have a portfolio that had maybe commodities, that had bonds in it. Well, each time we have an additional thing, we need to do the exact same thing. We need to say if this, then da-da-da-da. So we need to say if stock.type is equal to bond, then do the other stuff. And it will be slightly different for a bond. What we should really do is have a class that represents each of those types, so that we can literally just say get data, and it just gets data for the type. And these things are all defined within the class. That will be a far better way of doing it. It will be much more scalable because you don't need to change anything apart from adding a new class, and this will all deal with everything correctly. If we just said, stock, what have I done? If we just said stock.getData, it would get the data correctly because it would be within that stock object and it would handle it correctly depending on the type. Bit of design there that you might want to implement yourselves if you're watching the video, but it will make the video too long if we start doing stuff like that. So that looks all good. So now we need to go back and start doing the simulation stuff again. So again, sorry for any of you watching this, but this is going to be so familiar to if you saw the previous video. All we're doing there is we're getting the mean of the log returns. So this is a little Numpy array. We can just call the mean method. We'll get the mean. U is the, I've forgotten what the letter's called now, but in maths, mean looks like a U. We're going to get the variance of those log returns, so we just call var. I do explain this whole method a little bit better in the previous video. Drift, this is a really weird concept. Well, it's not really weird. For full explanation, see the Monte Carlo video. We need to get a standard deviation, a little statistical measure here that we like. Tell us about variance. T intervals, so this is the time we're going to be doing. That was a bad explanation. So basically what we're going to say is we're going to say how many times do we want to iterate over this thing. So we want to say days in year multiplied by years. Okay, so what this is going to do, what we're going to do here is T intervals is we are going to create a simulation and work out what percentage should we add to the current value of this stock every single day for the next 40 years. So there are 253 trading days on average in a year. There are 40 years, so you do the math, you work out how many intervals we've got here. But what we're going to do is each day we're going to add a tiny little percentage, or maybe we'll take some off depending on what the simulation tells us to do, and then we'll have all that and it will give us the value of that stock at the end, and then we'll use the weightings to figure out what the value of the total portfolio is. It's going to make more sense as we go along, just a little explanation as we go over. Next thing we need to do is we need to say iterations. Iterations, that's going to be 10. So that is the number of Monte Carlo simulations to run for each stock we pass in. So for each stock we're going to have 10 simulations, then we're going to do some stuff and we're going to get the geometric mean of the returns, and it's going to be slightly more accurate. There are better things we can do. We probably should run more iterations. It would just take longer for the program to run. So then we need to have this object called daily return. So what I was just saying a minute ago, where we're going to take these T intervals, we're going to add daily returns. So we're going to use a little bit of statistical magic here. Use that norm function we imported. Again, the Monte Carlo video has a slightly more in-depth explanation of these methods we're doing here. Iterations, like that. Okay, cool. So there we go. So now what we need to do is we need to get the first position. So it's called S0. We'll do I location. So that's essentially equivalent to getting, what we're going to do here is we're just going to get the very first thing. Is it the first or last? I can't remember. What we're doing is essentially, instead of saying like an array, normally you do array that to get the index of the array. We're just going to use iLock because I think this is a Numpy array. It is a Numpy array. I don't know why I said I think it is a Numpy array. Then we're going to get a price list, and we're going to firstly just fill it with zeros. So we say zeros, like, we'll say daily returns. All we're doing here is just creating a sort of empty array, well, an array filled with zeros that has the same shape as this daily returns thing here, because then we're going to change the values there as we go along. So let's get the first day. So price list 0 is equal to S0. Then we're going to say for T in range between 1, because we've already done the 0th one, we're going to say T intervals. And we're going to say price list T is equal to price list T minus 1. So this, now you see why we had the price list 0 set as this, because we're going to say this is the first day, right? This one here. So we're going to take the very first day we have, and we're going to start by adding the daily returns at the period T. So that is going to be, let's say, I don't know, let's say on that particular day, according to our statistical little measure here, we should add a % onto the value. So all we do is we say, what was the price yesterday? Add onto that. Sorry, not add onto that. What am I thinking? Multiply that by the percentage. So let's say, no, it's 100 on day 1. We say, oh, the return on that day was 1.01 or 1%, meaning that the next day it will be this. So then we're going to iterate over that again, and we're going to say 101. And let's say again, we did 0.1. Actually, let's say we'll do 10. I don't know if the maths is right. We're going to say it's that. Probably wrong. I don't know. It's actually probably something like that. Quick maths. No. But now you can see what we're sort of doing. We're going to do that for every single iteration. And remember, we have 40 times 253 iterations. And then we're going to do 10 simulations. Quite confusing names I've chosen. I do apologise. Okay, we've done that. We've got our little simulation of the prices. So now what do we need to do? Well, we need to figure out what the returns are. So we need to say, we need to say asset returns is equal to the price list at this point. So the last one divided by the price list at the first index. I just realised I explained this wrong earlier. This thing is not the first instance. This is the last point in the array. Basically, what we'll do is we'll start on this date. We'll get a load of data up to the current date or the last trading day. So what we want to do is we want to start with yesterday's trading data here, and then we start adding the prices onto that in the future. If we started with the 0th index, we would have actually started with the data here, and we'd be running a simulation over data we already have, and it would be really pointless. Sorry, the bad explanation there. Then we're going to do the geometric mean. So we're going to return the G mean of the asset returns. Okay. So this might seem weird, but what we're actually doing here is this price list contains the 10 iterations that we've done. So it contains those 10 different simulations. So what we're doing here is we're working out what the average return is across those 10 simulations, because the simulations can be really, really random. Well, that was stupid. A Monte Carlo simulation is essentially a random model to an extent. So you might have one, again, if you saw the previous video, you'd have seen the graph. You might have one return that's really up here, really high. The other one might be really low. So we're just going to sort of get the average of this. And the reason we're using the geometric mean is because we are using percentages here. And you want to use the geometric mean with percentages as opposed to absolute values. It's just more accurate to do that. Okay, so this should now, if we were to say, let's just, why is this not typing? Oh, okay, there we go. We should now be able to test what's going off. So let's see if we get in the stock. So we'll say, what do? We are going to say, let's say, we'll do get data, get portfolio, take the index 1 and we'll pass that. So we're only going to do it for 1 for the moment. We'll say Python main.py, we'll see what happens. It takes a bit of time. We've got a value error. What is the problem? I'm a turnip and I know what the issue is now. The issue is that we forgot to say what column we wanted. So it's saying about the shape of the array, because it's saying, oh, there's 6 here and there's 5 here. So in this case, the first time we ran it, we were running against 0. 0 is the FTSE 250 with the index. Number 1 would be the stock. The reason that's different is because we're going to hit these 2 different points here. We're going to hit here, then we're going to hit here. This will actually return a data frame that has 5 columns. Okay, so let's just prove this is correct. I'll print this, right? It's going to return 5. There you go. So it's actually returned them over here. We can see what we've got is we've got the date, although we don't count that as a column. Open, high, low, close, volume. The difference between what will get returned here is that we'll have a 5th column, the adjusted close. The adjusted close is a measure that accounts for stock splits. So what can happen when stocks occur? So let's say you've got 100 stocks, and I did explain this in the last video. You've got 100 shares of a stock, right? And the cost for each stock is £1, right? Which means that the market capitalisation of this company is £100. Now, suppose for a minute that for whatever reason, there are various reasons why management would do this of a company, but they say, you know what, let's split the stock. So they say, let's make 200 shares. So for every one of these shares, there are now 2. That doesn't mean the company is now worth £200, because what happens is the price would fall to 50p and the market capitalisation would remain at 100, because you can't just make more company out of splitting a company in half. Think about splitting a pizza. You cut a pizza up, you don't make more pizza by splitting it. Same thing with companies. So what the adjusted close does is it accounts for that sort of thing happening, because you could have like a price change of 50% in a day where really the price didn't change. By it basically assumes it normalizes the price. It's a normalized price of the stock across time. Now, the reason that we don't have this in here is because these are indexes. Indexes don't split, as far as I'm aware. So there's no need to have an adjusted close. So what we need to do is we need to say what column we want to get, because we're going to pass in the close, because we only care about what the price was at the close. And then for the stocks, we want to pass in the adjusted close like that. And if I was to run that again, we can get rid of this print line there. If we were to just run the Python script again, it should just work. Of course, it hasn't done anything because I haven't printed anything, because I'm an absolute moron. So we'll do this again. We'll print this and it should give us some interesting stuff. There we go. That gives us the return for that particular stock, the geometric mean of that price there. Right. So that should be all good. There's another thing we can also do here as well. I forgot to mention it, but we've got this daily savings value. What we can do here is we can add to the price list the daily savings. So we can say plus daily savings like that. And that will give you an idea of like how much it will grow, given that you're also putting money into the account. I'm going to leave that out because I just want to leave it out. But there, you can do it there if you wanted to do that. So, right, we've got that working. We've got this working. What else do we need to do? Well, the next things we need to do are we need to figure out what the expected return is. We need to do some messing around with the data and get us a nice output. So let's start saying this down here. So we'll say portfolio data is equal to get portfolio. So we'll call that in. Let's get the expected portfolio return. For this, we're going to have to write a method which we haven't written yet. So we'll say get expected portfolio return. That's going to be equal to get expected portfolio return. It's a long method name, bloody hell. And we're going to pass in the portfolio data. Actually, we do need to do something else. Actually, I've completely forgotten. We need to take the returns we get. So the returns we get from here, we need to take and add it to this little thing here. So we're going to create a data frame. So we're going to say portfolio is equal to PD data frame, right? And we're going to pass in the portfolio data like that. We're going to then say assign. What assign does is it allows us to add another column. because we don't actually have the returns here, because we don't know what they are yet. But what we're going to do is we're going to create this thing like over here. We have this is called a data frame. So we have these things are sort of going to be represented by the columns, but at the moment they're not represented by a column because they're represented in their individual objects. So what we would do is turn this into a thing that has tickers, that has the names in a column, has the weights, and then has the returns as well. But we don't have the returns yet, so we need to add that column. That's what we're currently doing. What the hell have I done there? Oh dear. Right, we'll just do that. Okay. So that's what we're going to do. So we're going to say assign, and we're going to use some lovely Python magic here. You're going to love this. So we're going to say returns. So that's the name of the column here that we're going to say. We're going to say that's going to be equal to, and it's going to be a little array. Say get data for that stock. Right? We're going to say for stock in portfolio data. Alright, that is great. Lovely one-line Pythonic way of doing things. We're just going to iterate through the stocks in the portfolio. We're going to get the data for each one, and for each one we're going to assign it to the returns column that we're just adding to a new data frame. Wonderful. Lovely Python stuff there. Then we need to pass this portfolio to the get expected portfolio return, which we haven't created yet, so let's go ahead and create that. Right, def get expected portfolio return, and we're going to pass in the portfolio. Should I call it the portfolio? Yeah, I'll call it portfolio. Oh well. What we're going to say? Well, we're going to say return numpy sum portfolio. And it's going to be the portfolio weight multiplied by the portfolio returns. Okay? So the weight is basically how much of that stock is allocated to the portfolio. So we've said we have a £1,000 portfolio here, which means 80% of that is dedicated entirely to this. So £800 goes there. For that, we want to work out what the actual overall portfolio return is. So we're going to figure out, okay, so how much did, say, this rise? Well, that rose by 10%. Well, multiply that by its weight of the portfolio. So of the whole portfolio, it works out, I think, 8% it will work out at. Maybe. I might be wrong there. But this works to do that. That's what we're going to do. So what do we need to do next? We need to, let's print that. Let's see what the expected portfolio return is. Okay, we'll do this. Oh god, I've done that wrong again. There we go. Portfolio data is not defined because I've spelt it wrong because I'm an absolute clown. Where have I spelt it wrong? On line 51. Portfolio data. No, portfolio data. There we go. Run that. Oh my god. We're messing more and more up. Again, I've done portfolio. Oh, I bet you're all screaming at the screens when you saw that happen. And there's nothing you could do because we're temporally separate. Right, so this is giving us the return. So it's saying over 40 years we're going to make 183%. This doesn't seem great. I think that's right, 183%. No, it's not. It's more than that. Yeah, it's more than that. Okay, right, so we've got the expected portfolio return. Let's figure out what the final value of the portfolio will be. In this case, we'll say expected portfolio return multiplied by the portfolio value. There we go. Have I done something wrong? I have a feeling I've done something wrong here, but this is going to that'll work. So now let's print stuff out here. What do we want to print out? We need to print out many things. Let's think about this. So we're going to print out the estimated value of the portfolio, value of portfolio in, see I spelled portfolio right this year, I don't know why I capitalised it, enter. Then we're going to add that pound symbol, which is why we needed to have this little thing up here. And we're going to not put a space between that. We're just going to say colon, comma, dot 2f. Now, what the hell is that? I'll tell you what that is. So, we're dealing with float values here. If you know anything about floating point arithmetic, it's not 100% accurate. In this case, it doesn't really matter because we're doing some random simulation, and so being off by a bit isn't really going to affect us. What we're doing here is we're going to format the floats to 2 decimal places. And we're going to say, put commas in between there so we can read the values a little bit easier. So we take this, colon, put commas between them, then format it to 2 decimal places. So that's very nice. Okay, then we want to say new line. Say expected, no space though, expected portfolio return is equal to, again, same sort of thing, comma, dot 2f. And then we want to pass in that. So we've got a percentage sign. Once we do that, we're going to say dot format. This line is getting way too long. Say date time. Dot now. So just get the current time. Get the year. Add on to that the years. Pass in the final value. So that's the second thing we were doing. And then we're going to also pass in that expected portfolio return. Multiply by 100. Yes. Okay, sorry. I see what I was thinking I'd done wrong earlier. I was thinking that we should be multiplying this by 100, but we don't need to do that because that's the correct percentage value. And we're going to show it as multiplied by 100 to actually get the percentage value to look correct. Let's say we also want to do something else. We want to also print out some other stuff. Probably should be in a separate print statement here. We're going to do what would the estimated income of this portfolio be? So what would you get in retirement from this portfolio if, you know, this is the portfolio you ended up with? So say comma dot 2f that dot format. Now, how do we get how much income we're going to do? Well, any of you know anything about finance will know that there's this rule in retirement that if you say you're going to retire at, like, I don't know, 60, it's reasonable to say, okay, estimate I'll have 30 years before I expire. Ooh, that was morbid. So they have the idea of a 4% drawdown rate. So if we take the final value of the portfolio and we multiply it by 4%, or, you know, we will get the expected income annually from this portfolio. Now, there are some problems with what I've done here. Notably, we haven't accounted for inflation, which I will leave for another video or for one of the lovely viewers to implement themselves, because it does get more complicated when you do that sort of thing. Okay, so we can now see that in 40 years' time, our estimated portfolio value will be £2,400 after we had a 247% return, and the estimated income for that would be £99. Okay, sorry for the jump cut there. I made a dog's ear of things and got completely confused with what I was doing and lost my mind. So, right, back to where we were. We had just done everything. Let's talk about some of the things we've missed from this video just to keep things short, so you might want to add some other stuff. So I've mentioned we haven't accounted for inflation, which we would want to do if we were going to be somewhat more accurate, because the value of the pound today is worth less tomorrow. So, you know, if I said to you, do you want a pound today or do you want a pound tomorrow? Everyone will say, I want a pound today, please. Which implies that there is a value in the future to money that is less than the current value. We also, and the idea of inflation is that the price of things in the future rises. So let's say inflation is the target. I think for UK inflation is around 2%. That allows for a nice level of economic growth, whilst not squeezing everyone's ability to pay for things. So what happens is prices rise by 2%, which means that the pound, or whatever currency we're talking about, loses 2% in value because it can't buy as many things anymore. In fact, it can buy 2% fewer things. So that's what inflation is. We haven't accounted for that because I didn't want to make this video too complicated. It's already quite long. We haven't gone to plotting the return so you can have a nice little pretty graph of this. We haven't gone and rebalanced the portfolio as we go. That's another one that we could have done, and it's very interesting. So what's happening here is, as we go on throughout the time, these weightings are changing as a result of the returns that these assets are making. Maybe this stock had a really good few returns, such that it doubled in value, then doubled in value again, and maybe it made it all the way up to being 50%, whilst this one still had quite a heavy weighting, and these two, because of it, fell down in the weighting. So one of the ideas we could do is we could do this thing called rebalancing, where each year we move things around. So maybe we sold some of this to give back to here, to here, to here, so we maintain these weights. We didn't cover that. These are more ideas for people to go ahead and do if they wanted to. We also haven't accounted for dividends. So for example, United Utilities is a utility stock, so it pays quite a large dividend and is quite stable price-wise. So the returns we're going to expect from that are going to be quite low, but when we factor in the dividend, it will bump it up quite a bit. We could also done some other stuff with the outputs, so we could have maybe given the max of the simulations and the min, sort of see what the range of them are, because like we say, we're just getting the geometric mean of them at the moment. We could have also done things like measure the risk of the portfolio. Now these are things I'm going to try and cover in future videos. Another thing we would also want to do as well is cover optimizations for the portfolio. Now this is more advanced stuff, so what we would love to try and do is say, well, here's the portfolio we have, but what are the optimum weights of the portfolio to maximize the return, the expected return, over a 40-year period, say? That's actually quite a complex problem, especially if we start saying, well, what's the optimal portfolio out of a sea of 250 stocks? That's actually, I believe, what you would classify as an NP hard problem, meaning we can't really properly solve it. We can only really approximate answers to it. So I've rambled on quite long enough. If you've enjoyed this video, please leave a like. If you want to ask questions, leave some comments. I do try and answer the vast majority of them. I do read them all as well. So thank you very much for watching. See you in the next one.